Problem 1 asks us on which intervals, if any, does the function f of x equals the square root of 2 minus x satisfy the hypothesis of the mean value theorem? Circle the intervals on which the function satisfies and explain briefly. So before I can even look at these intervals, it's really helpful to actually just do a domain check on the function, because I can see, because of this radical, that the domain of this function is not going to be all reals. So anything that goes outside of the domain of the function will automatically be excluded. So that's usually a good place to start. So the domain restriction that we have here is you cannot have a negative value under a square root. So I know that 2 minus x must be greater than or equal to 0. So then 2 must be greater than or equal to x. That means that my domain is from negative infinity to 2 included, because x has got to be less than or equal to 2. So if I look down here, the first thing I want to scan for is, well, are any of these intervals outside of this domain? So the first thing that I see is this interval goes from 0 to 3. So this interval is outside the domain of f. So MVT does not apply. The remaining two have intervals inside the domain, but in order to know if the MVT applies, I have to make sure that the conditions are met. So let's see if we meet the conditions that are required. So the first condition is that f is a function. This is in fact a function. So f is a function. F is continuous on its domain because it's a rational function, or excuse me, a root function. So f is continuous everywhere. So that means any interval included in this, it will also be continuous on. F is differentiable, right? So if we remember kind of how square root functions work, right? At 2, it just stops, right? The function doesn't go any further. So we have like a nice hard endpoint. So it is not going to be differentiable at 2, but it is differentiable on its open domain. So it's differentiable everywhere to negative infinity and everywhere but not including 2. So that means any interval that's inside of here, it's also differentiable. So now let's look at the remaining two intervals. 1 to 2 is in fact inside of these intervals. So remember the condition, it's got to be continuous, including 2, but it only has to be differentiable on the open interval. So this applies. So it works. Here, -4 to -3 is also inside our desired intervals. So we were told to circle the ones that work. So the interval is inside of here. So both of these functions are continuous on their closed interval. And f is differentiable on the open interval. So the MVT does apply. And that's all we need to do. Are the conditions met? And they are for those two.